Get ready, because in this video, I'm going to show you exactly how to run parallel agent swarms that run while you sleep. Everything in this visual at the end of the video will make complete sense to you. So let's get into it. Welcome to episode 4 of Agentic Engineering with Parallel Agent Swarms. In this video, I'm going to teach you how to manage a swarm. This is the fun stuff, right? This is having several agents at your disposal doing exactly what you want. This is what you've been looking forward to the entire course. What we're going to learn in this video is what are the advantages of parallel agents versus single agents, how to tend to an agent swarm, and how to set up a swarm to run on autopilot so that you don't even have to be there when the swarm is doing its work. I've asked many people that use parallel agents or single agents what the advantages of parallel agents are. And a lot of people don't seem to know. So I wanted to go over some of the advantages and the disadvantages of parallel agents so that you are aware. So speed obviously is an advantage, right? If you have 5 agents working on the same code base, they're going to be able to create that code base around 5 times faster than one single agent instance. Secondly, you get diversity. So if you have different types of agents like Codex and Claude Code, you can get a little bit of diversity of the code. That can be a little bit of a disadvantage because they're not quite as good at working with different types, but you do get a little bit of the next bullet from that, which is entropy. The way I would describe entropy in this sense is you get some unexpected diversity because each agent is going to go down a slightly different path, and that's going to make it so you get these varied opinions from the different agents that you wouldn't get if you had one agent working on one code base. So that entropy can give you some very interesting and thoughtful results that you wouldn't otherwise get with agents. To fully understand what I mean by this entropy part, you're going to have to try both. You're going to have to try using one agent and you're going to have to try using multiple, and I think you'll see what I mean. All right, and then finally we have redundancy. Redundancy is often seen as like a bad thing, but in some cases it can be a good thing. So redundancy reduces risk, right? So if you have one agent, you have a single point of failure. If that agent for some reason crashes or something like that, then your project will stop immediately. Whereas if you have several agents going, if one of them for some reason crashes or dies, you have other agents going and your project will probably continue. So those are the advantages, but there are actually disadvantages to parallel agents. One of the most immediate disadvantages that you will notice is that they tend to run into each other if you don't have the proper tooling in place. This makes sense. If you have 5 different people working on the same project, a level of coordination is required to make sure that they don't step on each other's toes. And then secondly, it tends to be less token efficient to use parallel agent swarms instead of one agent. The reason for that, frankly, is because it takes tokens to recognize and coordinate the other agents. So that coordination step does take up some tokens. So now that we've gone over the advantages and disadvantages of parallel agents, let us get into the essential elements. There are 3 essential elements that every agent swarm needs to function properly. I've tried removing all the elements from an agent swarm and just adding them back one by one and seeing exactly what was needed. And I can tell you that although there are a lot of tools in the Flywheel stack that we're going to use, these 3 account for 90% of the gains. The others are just tools. So here's what a swarm needs. Number 1, it needs a communication layer. The agents need to be able to talk to each other, and this is covered by MCP agent mail in the Flywheel stack. This keeps agents from trampling over each other while they're doing work. Secondly, they need a project management layer. In this case, our project management layer is beads, which we covered in the last video. Beads make it abundantly clear what the agents need to work on. If you make the agents try to guess what they're working on, they're oftentimes going to guess wrong, or they just might not work at all. And then lastly, we need a control panel to manage the agent swarm, because we still want to be able to have some visibility and intervene in the swarm if something happens, or we want to steer the swarm a certain way. And that's where NTM comes in the agent Flywheel stack, which we will see in action later. So I want to go over Once again, the agentic engineering workflow. In episode 2, we covered the plan step. That's the biggest portion, 80% of the work. In episode 3, we covered the beads step. And so that's where we turn this plan document into a fine granular set of beads that the agent swarm can attack. Now that we have the beads set up, and so the swarm step is what we're going to cover in the rest of this video. So I just want to give a brief reminder. I'm using the agent Flywheel stack. And so if you do want to follow along, go to agent-flywheel.com. This is completely free and open source. I didn't create it. It was created by this guy named Jeffrey Emanuel, who is an absolute wizard at orchestrating agents. And he made this incredible software, completely open source. It's great. So download this if you want to follow along. All right, so this is exactly where we left off in the last video. All the beads are created, and we can just verify that again by going BR stats. And we can see that it still has 152 beads, just where we left it. So now what we're going to do is we're going to first spin up a couple more agents. So we have one codex agent here. So if you remember NTM, that's our control panel. We're going to go NTM add. This is going to add 2 codex agents. And you might be thinking, why are you not adding any Claude Code? Because I do have a Claude Code subscription as well. Well, the reason I'm not adding Claude Code this time is because I actually want to test out that slash command. If the slash command works really well, then that might make the swarm even more autonomous than it usually is. I'm going to try with just codex this time, and we're going to see how it goes. So now you can see that 2 more codex agents have spawned. We're going to skip the update for now because this version of codex is perfectly fine. Thank you very much. Now, we have all of our agents spawned. We have 3 agents, and then we have this control panel right here. So now I'm going to go NTM palette. And this has a list of prompts that we can send to the agents. So you can see how beautiful this is. Instead of having to copy and paste all of our prompts to agents, we can store them in here and send them to the agents. And so there's a prompt here called default new agent, and that kind of comes out of the box with this NTM tool, but I modified it a little bit just to suit my needs. So I'm going to hit enter and then 1, and that's going to send them to each agent. And so you can see those prompts getting sent to the agent. And so that's it, guys. We have the agents going now. What they're going to do is they're going to read the prompts, they're going to read the agents.md file, and they're going to start working on the beads. It really was that simple. But now we have an agent swarm that is coordinated and it's going to work. So let's get into how you tend a swarm of agents like this. Well, you basically observe your agents, and this is what I recommend when you're first starting out, is that you observe your agents and get a feel for what they're working on. You can look and see what they're doing. And if any of them run into trouble or start doing something that you don't want, you can simply just type in how you want to steer their output. And so that's all well and good. But what if you want to send a custom prompt? Well, then we have another way of using NTM, which is NTM send. And then I can do So here I'm telling it to use SBH, which is a tool to check on how much of the VPS RAM is getting used. And because this is in Rust, and Rust is notoriously very RAM hungry when it compiles, I'm telling all of these guys to make sure that they use the SBH tool to make sure they're not overloading the VPS. So I'm going to hit enter, and that's going to send those to all of the panes. That's a really handy tool because it allows you to save prompts. That allows you to send prompts. What we can also do is we can go through the templates. So I can do NTM template list. And we can see these are all the templates of the prompts that I have saved. Most of these are out of the box, and then some of them I added myself. Point is, I can save prompts with the NTM tool. I can send them to the panes. It makes tending the swarm very convenient if you want to steer all the agents one direction, or you just want to send a saved prompt to one pane. It just makes this so convenient. And so that's why the control panel, or NTM, is really important for the user. Lastly, while these 3 agents are running, I want to go into why I chose 3 agents and not 12, right? What's the optimal amount of agents is a question that you should be asking yourself. When I first started out, I did run like 12 agents at a time and had them all clanking away. It looked so cool. But what ended up happening is they would really trip over each other, even with agent mail. And so even though it it looks cool to have like 12 agents going at once, oftentimes a project does not have enough parallel work for 12 agents to work on. The other thing is that the more agents there are, the more of the context gets consumed through coordination. If you have 12 agents trying to coordinate, they end up spending all of their context coordinating and almost none of their context actually coding. So it kills their productivity when you have a whole bunch of agents going at once. And then lastly, it'll tend to use up a lot of tokens, but not just that, it'll use up tokens really quickly. And if you are on Codex or Claude Code and we look at usage here, you can very quickly burn through your 5-hour limit if you have 12 agents running, right? And then your agents will have to stop because they'll hit their limit and then you'll have to start them up again. It's a lot more preferable to have them going at a pace that they can just consistently keep, because I've had my agents going for 18 hours at a time, right? And they just keep clanking away until the work is done. And that's perfectly fine. And then last but not least, the more agents you have running and compiling code, the more RAM you need to support them. And so unless you need your coding project to be done really, really quickly, lickety-split, and you're on a time crunch, maybe that could work for a hackathon or something like that. But most of the time, I find that 3 agents is like the sweet spot. So that's why I run 3 agents at a time. Side note, you see that all these agents are pursuing goal. That's because the thing that I added to that prompt from the beginning was that goal / command at the beginning. So Codex picked that up. And so now it's treating going through the beads as a goal. And I told it not to stop until all the beads are done. So what does that mean? Well, I just told you exactly how to make your agent swarm run autonomously without you having to be there. Now we can all walk away and just come back and this agent swarm will be done. So while you're tending your agent swarm, you can also check on the beads and see how the progress is going. So now we see that there's 148 open, 1 is already closed, and then 3 are in progress. That's exactly what we want to see. That means that each of these agents has 1 bead that they're working on. So that's perfect. So that means they're being productive. They're actually working through these. What you can do is you can keep running this command and coming back and seeing. So there you go. See, now there's 2 in progress and 2 closed. That means one of these agents completed a bead and moved it to done. It can sometimes be cool to tend to the swarm and see what they're doing, but honestly, at this point, we don't need to tend to the swarm anymore. It just looks cool, right? We gave them a goal, we gave them beads, they have those 3 essential elements that we talked about. They have the coordination layer, they have the project management layer, and then they have the control panel for us to use. And so this swarm is fully functioning and running on its own. So what we can do now is just walk away and come back in a few hours when all of these beads are. So just to give you an idea of the pacing, we're about half an hour in, as you can see, and they've completed 11 beads total. So this can vary based on how big the beads are, but you get the sense of how long this is going to take, right? Just multiply that by 15, and that's how long it'll take. So we're looking at about 7-8 hours here before all these beads are done. So what I can do is I can go to sleep and come back in the morning and check on these, and all the beads should be done. All right, so as you can see, they've been going for almost 10 hours. And that message right there was a hook for it to reread the agents.md. That happens when the context gets compacted. So yeah, they've been going for 10 hours, and let's check on the beads. So there are 11 beads open, 1's being worked on, and 7 are blocked. And we have 140 that are done. So they are almost done here. Let's also take a look at our usage. So we have only 18% remaining, so we're kind of cutting it close, but it resets in 15 minutes, so that means that we are still good. It's going to reset before we run out. And our instructions to use SBH worked because these agents did not crash the server by writing in Rust, which in the past has happened to me before. If we take a look at our repo here, we can see all the commits going back 2 minutes, 4 minutes, 5, 7, 11, 12, 15, and just kind of scroll all the way back, and they'll keep going back. So we're up to about 338 commits here. So this is nice because every time they commit, you can revert that if you want. If they do something that you don't want, then you can just go to whatever commit you liked before and just reversion it. So I try to get the agents to commit very frequently. Generally, they'll try to commit once per bead or even several times per bead. So you remember that we only had about 150 beads, and there are about twice as many commits already and a few beads left. So if we want to see which beads are ready too, we can also do BR ready. So there are some ready beads. Anyway, with this, we just kind of have to leave it alone and let it do its thing. Sometimes it ends up taking a little bit longer than you expect, but we're not in a rush if it takes an hour longer. All right, so they're all done, and it took them about 11 hours to complete. So now we can go to NTM. Okay, so this command should send the fresh review prompt to all panes. And what this is going to do is it's going to tell it to look over all the code that it just wrote with fresh eyes. So this can just be a really quick and easy sort of win to get it to look for problems and fix them before they occur. So now that we ran those and they completed, they found a couple errors that they fixed. Each one, you can go back and check the reports. But anyway, we can do now, we can go to the palette, and we can go check other agents' work. It's all of them. This one will generally take a little longer because you're asking it each one to go through the entire code base. And you might be thinking that they'll run into each other because they no longer have the beads to go off of, but actually with agent mail, they will not run into each other because this will get them to coordinate. See, we can see here, Copper Plateau sent to Fuchsia Bison and Mossy Mink. So these are the names that they assign themselves in agent mail. It's usually some color and object, but it can be different things, usually 2 words. Anyway, we're going to let them run. We're going to check codecs real quick. I still have 52% of my weekly limit. Okay, so with that, they're all done. So we can see that they took a little bit longer. This one took about 20 minutes, but overall not too bad. And we can see that the total number for this repo right now is 366 commits. Last commit was a couple minutes ago. So yeah, we can kind of look through the recent commits here over the past half hour. So we could keep sending improvement prompts to these agents, but I find after sending a couple to find the obvious errors, the best thing to do after that is to just use the thing and find the errors that way. Because no matter how many times you prompt them to find errors, eventually there are just going to be things that they don't catch or that they don't think is a problem, but you as a user do think is a problem. Because let's face it, these agents are not really using what they build. They're testing what they build. And there's a clear distinction there. They don't have a vested interest in making sure it works to their liking. And they certainly don't know what it means to make something work to your liking. So the next step is deployment, but that's something that I will have to cover in the next episode. And so with that, we have come to the end of this episode. So now this visual from the beginning should make perfect sense. So now you know what it's like for a bunch of agents to work on the same task in parallel. We know the advantages of having parallel agents: speed, diversity, entropy, that kind of randomness factor where each agent ends up going down basically its own separate journey, and that leads to differences. And finally, redundancy, for if one agent crashes or doesn't do the right thing, other agents can kind of pick up the work. Then the disadvantages is that they can sometimes run into each other if you don't have the proper tooling. Like if you don't have agent mail, for example, they will tend to run into each other. And then they are less token efficient. So agent mail does take up some of their context when they have to read their mail. And so overall, they're going to be less context efficient than running a single agent. There are 3 essential elements for agent orchestration, regardless of whether you use the agent Flywheel stack or whether you use a different stack like Gastown or Overstory. The essential elements are a communication layer to make sure that they don't run into each other, project management layer, which is just the beads to make sure that they are focused on the task at hand, and then finally a control panel for us mere mortals who are controlling the agent swarm. And then finally, I showed you how to actually deploy an agent swarm and get them to write good code and get them to write that code for hours at a time while we were sleeping. So that's all for this episode. This is really the most exciting part of agentic engineering, but it only works properly if you set up all your essential elements well ahead of time. Stay tuned for the next episode where I'm going to go into deployment and refinement. Let me know if you have any questions in the comments. I'll try to answer, and happy coding.